Everybody ready? Yeah, they should be. Everybody good? Solving logarithmic equations. Now, before we start this, I'm going to show you guys something that I didn't show you the other day. Whoops, not what I want. Hold up. You can go away. Something I didn't show you the other day that maybe I should have, but I decided to cut it out and not show you, is the graph of a logarithm. All right, and that's what I'm trying to zoom in on. Guys, stop talking. I'm zooming in on right here. All right. Now, if you look, right here, hold on. Okay, that's the graph of a logarithmic function. If you graph it, okay, that's the parent graph of it. This will be the only time we ever talk about it. Now, if you look closely, anybody know what a domain is?
Yes. We used to find a domain and range.
We used to find domain and range. Okay, what's domain? Domain is your what?
All possible.
Your x's. Your x's. Okay? They are the x's. They are the x's you can put into the function. All right? Make sense? The y's are the answers that you get out. Okay? The y's are the answers that you get out. So if you look at the parent function right over here, and you see the domain, it says all positive real numbers. What are positive real numbers? What Chamberlain said, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all your decimals in between. What does it not include? Negatives?
Fractions. Negative fractions.
Negative fractions.
Square roots.
What?
What's the square root of 25?
5.
5. There's a positive. Okay, so what? Same thing, square root of 25. It includes all positive real numbers. Includes any positive real number. Doesn't matter if it's rational, irrational, or fraction. Okay? It does not include your negatives and what? If it's a positive number, what does that not include? It doesn't include negatives. We said that. What else does it not include? 0. It doesn't include 0. Because 0 is what? 0 is neutral. 0 is not positive or negative. Okay? 0 is not positive or negative. So basically what this says is you cannot take the log of a negative number or 0. Okay? That's what I want you guys to get out of this. You cannot take the log of a negative number or 0. Alrighty? Now, that gets used today. Alright? There's no paragraphs in this slide, so you guys should be okay. Alright? But I'll post them later. Okay? So, the first one. Solve log base 36 of x equals 3 halves. Two things you need to notice about today's equations. Number one, they're pretty simple, to be honest. Okay. Number two, notice how many logs on either side you have. Okay. So log base 36 of x equals 3 halves. All right. Now, how many logs on either side? Or how many? Let me word it like this. How many sides have logs on them? 1. Okay, 1. Take note of that and how we do this. Okay. So you have log base 36 of x equals 3 halves. What do you think you're going to do? The same thing as last time. You're going to switch them. You're going to switch forms. X and 33 halves switch. You drop 30. You drop log. So 36 to 3 halves equals x. 36 is 6 squared to 3 halves. The squares cancel out, so 6 cubed equals x. So x equals 216. Okay, you plug that back in to x in the original, and make sure it's not a negative or 0. In this case, it's 216, so you're good. All right, so next, whoop, unfreeze. There. So the second one there, solve log base 9 of x equals 3 halves. It's kind of the same process every time you switch them. So 9 to the 3 halves power equals x. 9 is 3 squared. The squares cancel, so you're left with 3 cubed, which gives you, whoops, there we go. Looks like a 27. Got it. What's up? Yes. Yeah. Becomes 4 to the 5th, which equals x, which becomes, someone help me, is that 1024? Okay. So there's the first time. Jasmine? It's not much. I want to see you know the switch. I want to see that you know the switch. I want to see that you know to multiply your powers.
So I could just start in 4 squared 5?
Yes.
Alright.
If you want to skip, if you can skip, you can. I can see you skipping from, come on, from here down to here. Come on, work. There it goes. From there to there. I can see that. I can see you going conceivably from here to here, but I don't want to see you going from here to there. Okay? I want to see at least 2. Plus 2. Okay? That's type 1 when you have log on one side of the equation and you do a switch. Alright? Easy enough? The second type, and this gets much more difficult, is when you have logs on both sides of the equations. And in order to do that, we need this little thing called the property of equality for logarithmic functions. Here is what this thing says. If b is a positive number other than 1, b is your base, then log base b of x equals log base b of y if and only if x equals y. For example, if log base 5 of x equals log base 5 of 8, x equals 8. Translated, if you have the same base on both sides of your equation, what you take the quantity that you are taking the log of, air quotes, you can set equal to one another. It kind of goes back to your 7.2, where you broke down the numbers to get to the same base, right? You turn 64 into 4 squared, and then turn, or whatever, 64 into 4 cubed, there we go. And 16 to 4 squared to get your bases of 4, right? Yep. Once you got those bases of 4, you set your exponents equal to one another, right? And just kicked out the bases. Same thing here. Okay, same thing here. You're going to get the logs to have the same base. And once you do that, you can kick them to the side and solve whatever's left. So you're going to get it's a log base 5 of something equals log base 5 of something else, and set those somethings equal to one another. Okay? The nice part about this lesson is this. That's literally all you have to do. There's no moving logs around. There's no combining logs. It's literally, here's log base something of something, log base 5 of something, equals log base 5 of something else. You take the two somethings, you set them equal, and you solve. That's it. Okay, for this lesson. All right, questions? Everybody good up here? So, for example, solve log base 4 of the quantity. Now, parentheses are important here. You have to recognize what you are actually taking the log of. Okay, for this example, you're taking log base 4 of the entire thing, x plus 3. Equals log base 4 of the quantity 2x plus 1. Since you have log base 4s on both sides, and you're trying to just figure out what x is, you can use the property of logarithmic equality and cancel out the logs. Which leaves you with x plus 3 equals 2x plus 1. Okay. Well, how do you solve x plus 3 equals 2x plus 1? Subtract x from both sides. Subtract 1 from both sides. X equals 2. Log base 5s on both sides, so 2x plus 1 equals x plus 4, subtract x, subtract 1, x equals 3. Now, obviously, those were very two simple linear equations there. Those linear equations could become messier, all right, where you end up with 4x equals 12, and you divide by 4, get 3. Could be 4x equals 13, where you get a fraction. Anything's fair game there as far as your linear equations go. Okay, so just because the book wants to take it easy on you and give you both times x equals a number, doesn't mean I will. All right? Questions on that? So far, so good? Goody. Next one. Go ahead. Log base 2. Here we go. Log base 2 of x squared minus 4 equals log base 2 of 3x, which gives you x squared minus 4 equals 3x. What type of equation is this? Starts with a Q. Quadratic. And to solve a quadratic equation, you have about 5 different options, but the one we love the most starts with an F. Factor. So you make it equal 0. Get your two binomials.
Oh, so it multiplies to 2.
No.
Multiplies to 4. Adds up to 3.
Multiplies with negative 4, adds up to negative 3. So that'd be x minus plus 1, x minus.
You said it multiplies to negative?
Multiplies to your end, adds to your middle. Right? Just like if you would FOIL these back out, that's what they got to go to, right? So the last one has to multiply, the middle two had to add up. Okay, so x plus 1, x minus 4. From here, split them off. X equals negative 1, x equals 4. Okay, the log cannot be negative. Okay, so when you go and check these, see this 3x right here? See that? When I plug negative 1 in here, what am I going to get? Negative 3. So log base 2 of negative 3 cannot happen. That's not a thing, so negative 1 gets tossed. 4 is your answer. And just 4. Just like that.
What if both of them?
Okay? All right. Now, there are multiple cases here. All right? There are multiple different scenarios. You can get them where they both work. You can get them where they both don't work. You can get one where one works and one doesn't. Your safest bet is to check them. And the safest way to check them, honestly, is the one where you just have a multiplication of a number and a variable. See that? Because if it's a negative down here, you plug it in here, it's going to make it what? A negative, right? And then you know. But you got to make sure you check these. Good question, Jazz.
So like I couldn't check them like with the x squared minus 3.
You could. No, you got to go to the original. Because it's not what makes this stuff true. It's if these make it negative. You're changing the question on your checking. Okay? Because if you plug in -1 right here, you get -3. Plug in -1 over here, you get -3. You get a true statement up top. You get log base 2 of -3 equals log base 2 of -3. True. The issue is you can't have logs of negative numbers. So you're changing the question where you judge your checking. Make sense? Chamberlain.
If both are negative, would you put no solution?
Then you put no, if they're both negative and they both don't work, you put no solution.
But they won't work. Also, I thought it was just negative.
Log base 300
Oh my goodness.
of x squared minus 15 equals log base 300 of 2x. All right, now x squared or log base 300 of x squared minus 15 equals log base 300 of 2x. Yes, I will be the guy that gets obnoxious with my bases when they have no effect to your problem. So if there's obnoxious bases there, chances are you don't care. You don't care about the base 300. So x squared minus 15 equals 2x. It's a quadratic equation, so make it equal 0. X squared minus 2x minus 15 equals 0. 2 points about this problem. Number 1, when you factor, make sure your signs are right. X minus 5, x plus 3. Not the other way, because your signs have to go back to the other side. Okay? Split them off. So x minus 5 equals 0. X plus 3 equals 0. Yes, you can go straight to these answers of 5 and -3. That's fine. Okay? Now, let me tell you, from my point of view, you guys have to understand my rationale to this. I don't make you show me the check work. Okay? Because I think it should be easy enough that you do in your head. Okay? But right now, this person's losing at least half a point. Because what do I think?
That's your answer.
I think number 1, I think that's your answer. Okay. Hang tight. This person's definitely losing half a point. Why?
Because you said it.
Because one of those answers are not right. Okay. This person. Probably -0. You circle the one and not the other, I know you know that that one's right and that one's not.
That's not. Because you cross that out.
This person,
Full credit.
-0. You didn't circle that one, but you at least made the effort to cross that one out.
That's just a no.
All right.
Now, if you cross that out in the circle, then can you get plus 1?
Oh, yeah. Yes, sir.
This person,
Plus 5.
Plus a half.
you make me smile. Log base 12 of x minus 7 equals log base 12 of x plus 5. So x squared minus 7 equals x plus 5. Moving to the other side. You get x squared minus x minus 12 equals 0.
See, that's what I thought.
Okay? Shh. Listen. Guys, hey, we got 5 minutes. We got to finish this and talk about your stuff for the week. Okay? Now, factor this guy. Multiplies to -12, adds to -1. -4 plus 3. No, it doesn't. Whatever order. Okay? But it's the sign. The signs are what's important. So move this one to the other side. So x equals 4. Move this one to the other side. X equals -3. All right? Now, make sure you check these. You plug in 4. 4 squared, 16. 16 minus 7, 9. Over here, 4 plus 5, 9. Both sides, you get log base 12 of 9. Equal, you're good. -3. Plug it in. What's -3 plus 5? 2. What's -3 squared? 9. 9 minus 7? 2. Both sides you get log base 12 of 2. 2 is a positive. It's a positive inside your logs. They're both your answer. It's not what you get down here. It's what happens up top. If this up here ends up negative, then it doesn't work. I could finagle the numbers to the point where these are positives down here and they don't work up here. It's real easy to do. So make sure you check these real quick. Okay? Your assignment for this one's page 488, 9, 14 through 19, 26, 28.